Now one more important type of the problems involving in the chapter of the differential equation, that how to identify that problem is of very ordinary separable form, or it is homogeneous, or it is linear differential equation. So in my previous video I solved a question. I explained you that how to solve a problem in general if it is very easy to separate the terms of x with dx and y with dy. But if it is not possible, then problem either is of homogeneous category or is of linear differential. So now I am discussing a problem with the condition of homogeneous. So that the differential equation this is the differential equation x minus y dy by dx is equals to x plus 2y is homogeneous. We need to show that the differential equation given by x minus y into dy by dx is equals to x plus 2y is a homogeneous. It is a homogeneous equation, and then solve it. If it is homogeneous, then how to solve the homogeneous equations, this I want to tell you. First of all, what is the meaning of homogeneous? To check whether the given equation, differential equation, is homogeneous or not, we need to extract from the equation the value of dy by dx. The value of dy by dx is x plus 2y upon x minus y. From here, this x minus y is transferred in the right hand side and it has taken the place as denominator. To check homogeneous, as word specified homogeneous, the degree of numerator and denominator both should be same. So here the power is 1, power is 1, power is 1, power is 1. It is homogeneous. Net power, numerator minus denominator, is 0. So to check whether it is homogeneous or not, each term in numerator and denominator must have same power. First term of numerator, power 1. Numerator second term, power 1, power 1, power 1. So it is homogeneous, equal. Now method to solve such problems is, we always adopt let y is equals to vx. We usually take y is equals to vx, and on differentiating both sides, value of dy by dx become first v into derivative of second plus second into derivative of first. So we need to give the two replacements in this homogeneous equation. One of the replacement y is equal to vx at both the places. Another replacement is dy by dx equals to v into 1 plus x dv upon dx. So now on putting the values of y and dy by dx in this homogeneous equation, we will know that this dy by dx is replaced by v plus x dv upon dx is equals to, in place of dy by dx, v plus x into dv upon dx is equals to x plus y. This is 2y. So 2 into y means what? Vx divided by x minus y means vx. So what two major replacements you always needs to remember, that y will be replaced by vx and dy by dx will be replaced by v plus x dv upon dx. Now doing so, we have observed that x is common in the numerator. So this become 1 plus 2v. Here in denominator x is common, it is 1 minus v. X and x get cancelled. So we have noticed here this become v plus x dv upon dx is equals to 1 plus 2v upon 1 minus v. Now to solve it, this equation, it is very much possible to bring in the form so that it can be solved. To solve it, I am telling you that we should transfer the term containing the v from left side to right side. So we will take this situation, x dv upon dx in the left side is equals to 1 plus 2v upon 1 minus v minus of v upon 1, because this v is transferred from LHS to RHS. Now we will go to take its LCM. That LCM will be 1 minus v. So if we take the LCM as 1 minus v, then we can say 1 minus v is the LCM. So 1 plus 2v minus of v into 1 minus v is what? X dv upon dx. Now the question raised to solve it, that this become on simplification x dv upon dx is equals to 1 plus 2v, then it is minus of v, then minus minus plus v square. So this become v square, 2v minus v, this become plus v, and then plus 1 upon 1 minus v. After obtaining this result, we can think that how to solve this differential equation. This is our x dv upon dx is equals to v square plus v plus 1 upon 1 minus v. On cross multiplying, we will get x into dv is equals to v square plus v plus 1 upon 1 minus v into dx. We can shift this x in the denominator and this result here. What we will notice, what will be the form of the question to solve? That will be 1 minus v upon v square plus v plus 1. This is 1 minus v upon v square plus v plus 1 times of dv is equals to dx upon x. Because we need to separate the terms containing v with dv and terms containing x with dx. Now on integrating, because it is possible to integrate this part, we may use that linear differential equations. This we can use here one of the form that it is linear, it is quadratic. So a special category, that is the numerator is equal to lambda times of differentiation of denominator plus mu, and dx upon x is clearly log x. So we will solve now this differential equation with the help of substitution and some other arrangements of our integration. Now with the help of some transformations, we will get to know that the value of its integration is half log mod of v square plus v plus 1 minus root 3 tan inverse of 2v plus 1 upon root 3 plus half log x square plus c1 is equals to, you can say, if all data is transferred here, 0. Now as in initially I explained you that we were assumed two things. I have told you to assume two things. One was, as it was the homogeneous y is equals to vx, and other replacement was in place of dy by dx, what was replaced? V plus dv upon dx. Here there is no rule to give the reverse back of this situation, but from this y is equals to vx, we can say v is equals to y upon x. So this y upon x, on putting v is equals to y upon x in this solved integration form, we will get to know what is the final answer of the question. If we put v is equals to y upon x here, here, so what will be the answer? It will be log of mod of x square plus xy plus y square is equals to 2 root 3 tan inverse of x plus 2y upon root 3x plus integrating constant c. So in this way, it is very easy to solve the differential equations of the form homogeneous as it was required. First we have proved it is homogeneous, and later we have solved by assuming this y is equals to vx and dy by dx is equals to v plus x dv upon dx. So there were two assumptions. This was x here, then the answer has come out like this with total number of steps and details.